I think he is a very cool man， 因为他自己自干了一个音乐的工具，帮助他去在做音乐的过程中，可以很好的听到乐器的模拟声音。这是一开始他想用的这个工具 iOS 上有，任何的作业系统上也有，但是在 Android 上没有，所以秉持着我们的黑客精神，他自己自改了一个。另外，个人觉得他另外一个很酷的地方，他在家里弄了一个小小的录音室，为了自己的兴趣跟想做的事打造这一个热情的投入，我都觉得是一件很不容易的事情。Okay. Maybe when 1 minute will stop.
Do you mean from 1 minute now? Or 1 minute from now?
Because our devices. Okay, it's okay now. Great, your turn.
Okay, thank you. Okay, 大家好，我叫Atsushi. Excuse me, my Chinese is not great, so let me switch to English. Thank you for coming to my session for designing audio plugin framework for Android. I'm Atsushi Eno from Tokyo, in Tokyo now. I used to live in Taiwan a couple of times, but now, for obvious reasons, I'm stuck in Tokyo now. I'm reachable through GitHub, SpeakerDeck, Google, Facebook, Twitter, in the name of Atsushi Eno. I also shared my slides on SpeakerDeck already, so if you are curious and want to see them ahead of me, just go there and find it. Okay, let's get started. I'm going to talk about how to compose music using software. How do we compose music in real world? Because we usually use score sheets, right, like the left image, or sometimes something like guitar tabs, and then we use instruments or vocals in the real world. How about composing music with PC software? Typically, we use software called Digital Audio Workstation, DAW or DAW. We use this software to compose like each tracks, guitar tracks, bass tracks, drum tracks, vocal tracks, that kind of. And then we use something like raw audio with voice recording or software instruments using audio plugins. There are some software called audio plugins, like you would have heard of software Hatsune before, chewing in Chinese. They are actually a software and it's different from vocals, raw recording vocals. We also use some software synthesizers as well. And lastly, we use devices called MIDI devices, which lets you play like real instruments like keyboard on the screen on the right side, turns your playing into instructions to digital audio workstations. Okay, let's switch to audio plugins. What are audio plugins actually? There are two kinds of audio plugins in the world. The first category is instruments. The leftmost slide image on the screen right now is a drum, which looks like a real drum, but it's actually a synthesizer. If you click on the application, it gives you some drum sounds. So right next one to the drum synthesizer is a famous synthesizer called Serum, which is used by many EDM music. Those instruments accept some keyboard inputs from MIDI devices and then turn them to a waveform. The second category of audio plugins is the amplifiers. The right next one is a screenshot from the effects, which has some parameters like dry, or two phone categories effect the level. The rightmost one is also a famous plugin for equalizer from the company called Isotope. Those effectors take audio input, route of waveform into another and make them into another waveform. And lastly, I'm going to talk about audio plugin framework. What is a framework? For DAW softwares and plugin softwares, they need some common interface to talk to each other. Otherwise, it cannot be communicated. And for such use, audio plugin framework is needed to make them interoperable. There are a couple of existing audio plugin frameworks already in the world. The most popular one is software called VST, Virtual Studio Technology, from a company called Steinberg, which is now technically part of Yamaha. The VST began with only with Windows, but it has extended its support to Mac OS and recently Linux as well. The Linux support is still embedded, but it works quite well. Apple had its own audio plugin framework called Audio Unit. It had extended its support to iOS because Mac and iOS have a lot of common shared API. How about Linux? Linux has its own world called. It has a popular audio plugin framework called LV2, which where the V2 is a Ladospa version 2. The Ladospa was a famous popular audio plugin framework in the past. How about Android? Android has no audio plugin framework in the world so far. It never happened with the biggest reason is that Android audio story was not great before. It had a lot of audio latency before. And softwares like those didn't work well. That was it's changing. I thought that it's time to bring it to bring my own framework to this world. So I developed an experimental research project called AAE and audio plugin. Let me show you some demo. Can you switch to the YouTube video now and switch to plugin? Tell me if it's good to begin. Okay, let's go. So, before talking about this demo, I should say that this is not a DAW. When we audio plugin developers test our plugins, we don't really use DAWs because it's too complicated. Instead, we use simpler software called plugin hosts, just hosts. And that is such a software. And this video has, so this video I had a couple of input and effects towards audio outputs. Excuse me for some noises. It's generating some sounds from some synthesizer to with some effects. I just turned off some effects on the front. I'm turning off a couple of other plugins. Input the sound simpler now. And synthesize only with a simple synthesizer and plunger. I disable the plunger now. It's much simpler, right? You will hear some slight difference. And then adjust to the synthesizer. Even simpler. Now enabling some effects. It is with overdrive. And lastly, with detune. The sound is obviously different there, right? Okay, let's go back to the slides. And let me resume and go back to slides. So since I'm developing some audio plugin framework, I need to make it greater. And to bring a great audio plugin framework, I need to care about a couple of keys to successful success. And it is common to audio plugins as well. So let's go. Obviously, the first thing that I should think about is to bring how to make a bigger ecosystem, because without any, for example, without any plugins, those developers wouldn't like to support my plugin framework because it's just a waste of time. The same happens to the audio plugin developers, because if there's no demos and support me, then it doesn't make sense. But to understand how to achieve that, we should understand what audio plugin developers do. Actually, how to develop their plugins. The first thing they do is obviously to design the audio plugin, what it is like, what kind of parameters it has. And then, second is to actually write code for that. It is usually, the interface itself is usually simple because it only accepts MIDI inputs and audio inputs to audio outputs, and sometimes video outputs as well. And the third thing is to design the user interface to users. It can be simple sliders or simple buttons like HTML UI, but usually they come up with more complicated plugin UIs. And lastly, they have to package their audio plugin into the real plugin formats. If they are only interested in making VST, then they just work on VST. But if they want to support Mac users as well, then they will have to package for audio units as well. And if they are great and want to support Linux as well, then they will package for Q32 as well. Packaging everything is quite difficult. But a lot of those tasks are actually cross-platform, including the UIs. Like you wouldn't know a couple of cross-platform UI technology. But the audio plugin processing thing is really cross-platform for audio plugin developers' point of view. The hosts are different, but plugins are quite cross-platform. There are a couple of existing cross-platform frameworks that supports developing many audio plugin formats. Maybe the most known one is called Juice, which is GPL software, but also commercially available. And it supports VST speed. Well, 2 is already dropped on VST speed now. They also support audio unit. And some community people have extended Juice because it's a free software to support LV2 as well. But I thought that if I support my own framework and by extending Jews, it would bring more plugins in my world. It's much less effort than I thought money. I actually believe that another way to bring existing value to my world is to wrap up the existing framework. By writing some content wrappers that other formats into my formats to let so that other plugins work as if they are working as in my format. It would be much simpler than porting them as well. So I wrote MV2 wrapper to my plugin framework. So in the beginning, I already have two major-ish formats to my world. That's the way how I try to achieve bigger ecosystem with much less effort. The second key is to successful audio plugin framework is to keep API and API stable and extensible. That means like if I keep breaking changes to my audio plugin framework, that means some softwares that used to support my framework will become incompatible with the latest version. They will get out of the bigger ecosystem. That goes against the first principle. So it is important to keep API stable. This last item is the most difficult thing, is to for developers to meet real-time audio requirements. I need more explanation. What is real-time audio requirements? In general, audio processing can be done real-time. By real-time, I mean usually like every second issue, one cycle. And if it goes more than like 20 milliseconds, the professional musicians will notice some glitches or it will bring some noises. Think about say every music class has to be processed in time. But think about your experience with elementary school or junior high school. You will have played some music together with everyone else in the classroom. Everyone has each instruments. If you play slower or someone plays faster, the entire playing sounds awkward. So they have to be played just in time together. Real-time audio processing requirements like that. Real-time does not necessarily mean high performance. There are many existing high performance framework or languages like Java or .NET or Go. They have very nice high performing virtual machines. Like sometimes they support C++ code. Sometimes. But they also come with some drawbacks. So some of those drawbacks are real-time blockers. For example, they come with garbage collector. A garbage collector is a framework that the developers don't have to worry about freeing memories that they allocate in the program. If they don't have to worry about free memory, there's something called garbage collector thread that handles free memories. Garbage collectors, when they work, stop every other application threads and mark every memory usage, and then if they are ready to free, then they mark the memory area to free, and they resume every other application thread, and then it frees the memory. But real-time audio thread is also stopped, and then it is not really great for real-time processing. So, Java, Go, and those languages that come with JavaScript are no go with real-time audio processing. That is really tough to require. Same was the JIT compiler. We combining some non-native code, virtual machine code with native code. But it can take possibly a lot of time, and then it doesn't meet real-time requirement. Idle operation, of course, doesn't. The script blocking of the script as well, like if it's blocking out the script, it's not great for real-time. Actually, there are many POSIX system calls that don't meet this requirement. For example, I also had some projects for audio plugins, and I received some bug reports from some dog developer. And I was using a fork function in my plugin to separate the UI processing and audio processing. The report told me that I shouldn't use fork because it involves some file copy operation and copy on write. When I received this report, I was like, what the fuck? Oh my god, it's super difficult. Actually, it is quite difficult topic. If you are interested in real-time audio processing, you would like to check a video from real-time audio processing stuff from Audio Developers Conference last year. Okay, lastly, I should talk about some unrealistic issues. There are a couple of issues I have to deal with. One difficult one would be app distribution difference. It ties to the second difficult points that any Android application cannot load shared library, benefit library from other, which is not dialog from other. Android application can dialog from using its own application, but can't from not from other application. Which is in typical desktop application and desktop node, we can simply load audio plugin as a shared library in process. It's much simpler. For Android, we have to process audio data through remote procedure calls, which is in the red line and red arrow from this arrow to the right. Unfortunately, Android came with some nicer nicer IPC framework called Binder, which is Android 1. But it didn't really come up with native solution until very recently. But finally, Android 10 started to support Android native Binder API. So I made use of this API, so my framework has SDK level 99, which is really limited, very strict restriction, but it's kind of open because it's still research extent. And by the time people are waiting, I don't feel really get more. If you are interested in there's some great slides and presentation from a Taiwanese guy, Joseph Jin Huang. Maybe many of you would be more familiar with him. He had this presentation many years ago. And it has a couple of drawbacks like mutex, but it's kind of occasional compared to garbage collectors. I also had to use shared memory to process everything. Let's go back to the last item on this slide. The last difficulty is like Android usually has only one active foreground application. But if you switch from DAW to audio plugin to adjust audio plugin parameters, the plugin activity will become faulty. You only get one foreground activity and the DAW goes back up, and that's quite difficult. That's not really quick. So what I'm thinking is to bring some web view-based UI like HTML. May sound awkward, but it's probably possible. There are a couple of some existing experience with HTML-based UI in the world. I also came up with my proof of concept problem that considers HTML web view only for desktop software. Don't be important to Android now. It's still a research topic. There are a couple many other concerns and thoughts, like maybe I should maybe do one there, or maybe I should attend Okay, so it's almost over. I had this session I covered, but there is no audio file kernel in the world yet. Only one. I only have some audio on the bottom. They are from other world. I also have a couple of difficult topics. Lastly, let me have links to my records so far. They are still research projects, so they're not really useful. So try to use it. We were very interested in source code. Okay, so I'm done from my side. Thank you so much.
So, you're the 可以，你可以
先阐述你的问题，然后我们会帮你想这个问题。
可以让我问他，他是如何去做 RealTime 的 audio 的 performance 的 profile。RealTime 的 audio performance profile， 跟其他简单的 share 一下。
Hi. So, one of the audience want to know how do you do the real-time audio performance profile video.
不然我直接讲吧。
好。
Can you repeat the question again?
My name is Gary. My question is how do you two profile your real-time performance on Android?
Right. The question is about profiling
On Android.
on Android. Well, so far I only have performed very simple and stupid profiling by putting some logging lines between before and after audio processing at host side that should involve the turnaround time containing IPC processing time. And they were like hundreds of 300 to 400 milliseconds. No, microseconds. Sorry, millisecond is horrible. Microseconds for each processing. So I think it's still kind of acceptable. iOS has some similar drawback, like they also have isolated processing. They have in-app audio stuff, but people say that they only process 3 or 4 plugins at a time. So in the Android world, in my world, it would be similar, I guess. Does that answer to your question?
Yes. Thank you. So,
Alright.
还有人我有问题吗？没有。Okay, and now there's no other question. So thank you for coming and sharing your project today.
Thank you so much, guys.
See you.
Bye.